crude oil. This viscous black liquid is often called black gold. It is the lifeblood of our modern world. Economies depend on it. Industries rely on its energy. It fuels our cars. It heats our homes. For over a century, crude oil has been the dominant source of energy. This dominance stems from its abundance, relative ease of extraction, and high energy density. Crude oil's impact on the global economy is undeniable. It is a major commodity traded on international markets. Its price fluctuations can send ripples across the world, affecting everything from transportation costs to the prices of everyday goods. The importance of crude oil extends far beyond its role as an energy source. It serves as a crucial raw material for a vast array of products. Plastics, fertilizers, and synthetic fabrics all originate from crude oil. Our modern way of life, from the cars we drive to the clothes we wear, is deeply intertwined with this fossil fuel. As we move further into the 21st century, the demand for crude oil continues to grow. Emerging economies are experiencing rapid industrialization and urbanization. This drives an insatiable need for energy and petroleum-based products. Despite the push for renewable energy sources, crude oil is likely to remain a cornerstone of the global economy for the foreseeable future. The journey of crude oil begins deep beneath the Earth's surface. Over millions of years, organic matter, primarily ancient marine organisms, accumulated and were buried under layers of sediment. Heat and pressure transformed this organic matter into the hydrocarbons we know as crude oil. Locating and extracting this black gold is a complex and technologically demanding endeavor. Geologists use sophisticated techniques like seismic surveys to identify potential oil reservoirs. Once a promising site is found, drilling rigs are erected and wells are drilled thousands of feet below the surface, often offshore in deep ocean waters. The extracted crude oil is a complex mixture of hydrocarbons. It is not in a usable form. It undergoes an initial processing stage near the extraction site. This removes impurities like water, sediment, and salt. This crude oil is then transported, often via pipelines or tankers, to refineries around the world. Here, it undergoes a remarkable transformation. The heart of a crude oil refinery is the distillation unit. This towering structure is a marvel of engineering. Here, the complex mixture of hydrocarbons undergoes its first major transformation. Distillation separates crude oil into its various components based on their boiling points. Think of it like boiling a pot of water. As the water heats up, steam rises. The steam is collected and cooled, condensing back into water. In distillation, crude oil is heated in a furnace. This vaporizes the hydrocarbons. The vapors then rise through a distillation tower which contains a series of trays. Each tray is designed to collect a specific hydrocarbon fraction at its respective boiling point. Lighter hydrocarbons like gasoline have lower boiling points and condense in the upper trays. Heavier hydrocarbons like diesel fuel have higher boiling points and condense in lower trays. The separated fractions are then drawn off and sent for further processing. Distillation alone doesn't meet the demand for lighter hydrocarbons like gasoline. That's where cracking comes in. Cracking is a chemical process that breaks down heavier hydrocarbon molecules into lighter ones. Imagine taking a long chain and breaking it into several smaller chains. That's essentially what cracking does. There are two main methods of cracking: thermal cracking and catalytic cracking. Thermal cracking uses high temperatures and pressure to break down the molecules. Catalytic cracking, a more efficient process, uses a catalyst to speed up the reaction at lower temperatures. Cracking is crucial for maximizing gasoline production from crude oil. It helps meet the global demand for this essential fuel. Without cracking, a significant portion of crude oil would be unusable for gasoline production. Section 5. Reforming molecular rearrangement. Reforming is another essential process in oil refining. Unlike cracking, which breaks down molecules, reforming rearranges the structure of hydrocarbon molecules to improve their properties. It's like, rearranging the pieces of a puzzle to create a different, more desirable picture. Reforming primarily targets the improvement of gasoline quality. It increases the octane number of gasoline, making it burn more efficiently in engines and reducing harmful emissions. Reforming is a complex process that uses heat, pressure, and catalysts to rearrange the molecular structure of hydrocarbons. One of the main products of reforming is high-octane gasoline. This is essential for modern high-compression engines. Reforming also produces aromatics which are used as feedstocks for the petrochemical industry. Section 6. A cornucopia of products from fuels to plastics. Crude oil refining yields an astonishing array of products that are essential to our modern way of life. These products touch nearly every aspect of our daily lives, from transportation to consumer goods. The most well-known products are fuels. Gasoline powers our cars and trucks. Diesel fuel fuels our heavy machinery and some vehicles. Jet fuel propels airplanes across the skies. Heating oil keeps homes and buildings warm. But the reach of crude oil extends far beyond fuels. It is a key ingredient in the production of petrochemicals. These petrochemicals are the building blocks for countless products, including plastics, fertilizers, synthetic fabrics, and pharmaceuticals. From the clothes we wear to the medical devices that keep us healthy, the influence of crude oil is undeniable. Section 7. The environmental price of refinement. While crude oil refining is essential for our modern world, it comes at a significant environmental cost. The refining process itself is energy-intensive and releases harmful pollutants into the atmosphere. These pollutants contribute to air pollution, smog, and acid rain, impacting human health and the environment. Furthermore, the combustion of fossil fuels, including refined petroleum products, is a major contributor to greenhouse gas emissions. These emissions are the primary driver of climate change. Addressing the environmental impact of crude oil refining is crucial for a sustainable future. Efforts are underway to mitigate these environmental impacts. Refineries are adopting cleaner technologies and stricter environmental regulations. The transition to renewable energy sources and the development of more sustainable production methods are also essential steps in reducing our dependence on fossil fuels. Section 8. Refining innovation towards a sustainable future. The oil and gas industry is continuously evolving. Driven by environmental concerns and the need for greater efficiency, the future of oil refining lies in innovation. Advanced technologies are being developed and implemented to minimize the environmental footprint of refining operations. One promising avenue is carbon capture and storage, or CCS. This technology captures carbon dioxide emissions from refineries and stores them underground, preventing their release into the atmosphere. CCS has the potential to significantly reduce the carbon footprint of oil refining. Another area of innovation is the development of bio-based fuels and chemicals. These renewable alternatives to petroleum-based products are derived from plant-based sources, offering a more sustainable approach to meeting our energy and material needs. As technology advances, we can expect to see even more innovative solutions emerge. Section 9. Conclusion: a future inextricably tied to oil. Crude oil refining has played a pivotal role in shaping the modern world. It has provided the energy and materials that fuel our economies, power our transportation systems, and enhance our quality of life. However, we must also acknowledge the environmental challenges associated with this vital industry. As we look to the future, the need for innovation in crude oil refining is clear. We must continue to develop and implement technologies that minimize environmental impact, improve efficiency, and reduce our reliance on fossil fuels. The journey towards a more sustainable future will require a multifaceted approach. It involves embracing renewable energy sources, promoting energy efficiency, and fostering innovation in all sectors of the economy. While the transition to a cleaner, more sustainable energy future is underway, crude oil refining will likely remain an integral part of the global energy landscape for the foreseeable future. By embracing innovation and responsible practices, we can strive to meet our energy needs while mitigating the environmental impact, ensuring a brighter future for generations to come.